Guys, welcome back to another video, and in this video we're going to be continuing on with our SwiftUI tutorial series, and in this particular tutorial we are going to be taking a look at UIViewControllerRepresentable in SwiftUI. Now, what is UIViewControllerRepresentable? Well, UIViewControllerRepresentable is a way for us in SwiftUI to wrap UIKit views in a SwiftUI view. Because SwiftUI doesn't exactly have everything that UIKit does. And maybe there are UIKit view controllers in your existing applications that you may need to wrap into SwiftUI views until you can create native SwiftUI versions of those view controllers. So this is why UIViewControllerRepresentable exists. Alright, let's go ahead and go into Xcode, and I will explain what we're going to do here. Alright. So in Xcode here, what we're going to do is we're going to create a UIViewControllerRepresentable that wraps a UI collection view controller into a SwiftUI view. Now, why are we wrapping a UI collection view controller into a SwiftUI view when we already have things like lazy hgrid and lazy vgrid and list, which technically uses collection view under the scenes? Behind the scenes. Well, maybe you need something a little bit more performant than what SwiftUI can provide you, and this is one way to do it, by wrapping a native SwiftUI, or wrapping a native UIKit view in a SwiftUI view, so things are a little bit more performant. Okay, so what I want you to do is I want you to create a new file. And I'm just going to make this a Swift file, and we'll call this colors grid view. All right. And inside of this file, instead of importing foundation, we will import SwiftUI. And then we'll say struct colors grid view. Have this conform to UIViewControllerRepresentable, not restoration. Then UIViewControllerRepresentable. There we go. Now, Xcode is going to yell at us, and it basically is telling us we're not conforming to the protocol that we need to conform to. So what we're going to do is we're going to say we want, let's see, it should be N and not NS, UI. Well, what we can do instead is we can right-click on Colors Grid, and under Refactor, we want Add Missing Protocol Requirements. Now, the first thing that we have here is a type alias. The type here will be UI collection view controller. All right. And then with that, we can get rid of everything else that's here We'll get rid of that. And then again, we will refactor, add missing protocol requirements, and now it comes back with less stuff than before. All right. So all we have here that it gave us is it gave us a function make UIViewController, and this is going to return a UIViewController instance, so in this case a UI collection view controller. The second thing we're given is update UIViewController. So inside of this method we would update the UIViewController if necessary. And then optionally we can put in a make coordinator. A make coordinator method here. And we'll talk about what those are when we get to it. But for now, what we want is we need to have some code inside of our make UIViewController. Now, if you're familiar with how UIViewController or UI collection view controller rather works, this has a built-in collection view already for us. We'll just need to configure that collection view, and we'll need to make sure that we specify. We need to make sure that we give it a specific collection view layout, because if we don't initialize a collection view controller with no layout, it'll crash our app, and we don't want that. So let's go ahead and get started with that. By saying let collection view controller, or CVC, equals UI collection view controller, and we want the one with a collection view layout. So, what this collection view layout is going to do is it's going to specify how exactly our items in our collection view are laid out. And there are many different kinds of layouts, but we're going to use the UI collection view flow layout. So, we'll just call it layout. And above our CVC, we'll say let layout equals UI collection view layout, or UI collection view flow layout. And then we will have that call its initializer. Then we can configure our layout. So layout dot scroll direction. So what direction do we want our collection view controller to scroll? And in this case, we will have it scroll vertically. Layout dot we have minimum line spacing and minimum inter-item spacing. Now, minimum line spacing, this basically is the minimum amount of spacing to use between the various lines of items in our collection view. And we'll set this to 20. And then we'll have layout dot minimum inter item spacing. This will pretty much be the minimum amount of spacing that we want between each item in the collection view rather than each line of items. And we'll set that to 20 as well to keep it even. And then there are many other kinds of properties that we can use here. For example, the item size. We'll set the item size to a CG size with a width of, we'll say 50, and a height of, we'll say 3 times that, so 150. All right. And that's really all we're going to need for this, for our layout. Now we can safely configure the rest of our collection view controller. So the next thing that we're going to configure about our collection view controller is its delegate and data source. Now, if you're unfamiliar, pretty much the collection view will have this thing called a delegate and a data source. This is a UIKit specific thing in the world of iOS. It's a pattern called delegation, where some other object performs an action, but the collection view doesn't care what that action is as long as it gets done. You can think of it as a boss-intern analogy, where the boss, in this case, it will be the collection view, and the intern is the object that performs these different tasks that the boss tells it to perform. The boss doesn't care, right, how the intern does the task. It just cares that it gets done. All right, so that's kind of how that works. It's a little bit different of a way of doing things than you would in just plain SwiftUI. But if you want to incorporate UIKit views into your SwiftUI apps, you must understand, even at a minimum, the basics of how UIKit works. And if you're using, and if you need to embed AppKit view controllers and views into your SwiftUI apps, you'll need to understand the basics of how AppKit works, which is very similar to how UIKit works. So just keep in mind that's how that's going to be. All right. So now we'll say CVC dot. We will want the collection view dot delegate will be equal to context. So context is one of the parameters passed in to make UIViewController, and from this we will get the coordinator object. Now, in order to create our own coordinator object, which is the object we will use to conform to the delegate and data source protocols, we need the make coordinator method from UIViewControllerRepresentable. But we're going to do that here in a second. All right. Next, we'll need cvc.collectionView dot data source is equal to context dot coordinator. All right, cool. All right. And that should be all that we need here for that. All right. Now we can return CVC. And that is our make UIViewController method. All we're doing is configuring some kind of view controller and then returning it. So SwiftUI knows what view controller to use for its SwiftUI view. Now, we don't need anything inside of update UIViewController because of the fact that we don't have any state that we're going to handle here. If we did, if we wanted to have modifiers for our views that conform to UIViewControllerRepresentable, we would need to do stuff in update UIViewController. But for now, we can leave this empty. If you wanted to, you could, in this example, you could have modifiers that could modify the view controllers, the collection view flow layout. So you could have modifiers to set custom spacing, a scroll direction, stuff like that. But we're not going to do that here. Now, above update UIViewController, what I want you to do is say make coordinator. Now, what this is going to return is we're going to return a coordinator. And this, we're simply going to say return coordinator. But this coordinator is going to take in some colors. And we'll say colors. Now, we don't have a coordinator class, nor do we have an initializer in that coordinator class that is given colors, and we don't have an initializer for this view that takes in an array of colors. So what we'll do is at the top of our file here, before we have our make UIViewController, we'll say var colors, make that an array of color, and then have an initializer that takes in an array of color objects. And then we'll say self.colors equals colors, like that. We'll have in it colors, an array of color objects. We'll open that up to say self colors equals colors, like that. And we're good. So what we'll do at this point is we will create a class called coordinator. I'm going to put this beneath our view here while making this an extension of our view. So extension colors grid view here we'll say class coordinator. This is going to inherit from NS object UI collection view delegate, and it's also going to conform to UI collection view data source, like that. And so far, our collection view doesn't conform to anything, and that's fine. But we want to have a var colors, an array of color objects, like that. And then we'll have an initializer that takes in that array of colors. We'll say self colors equals colors. Colors, like that. And now we have that error gone away where it says, oh, we don't have an initializer that takes that parameter. Now we need to actually conform to the delegate and data source. So we'll say collection view. We don't want can edit or can move. We want self or item at. We want number of sections. And then we want number of items in section. These are the ones that we want. And then this error should go away that we're not conforming to the protocol, but now we should get errors that we're not returning something where we should. So let's go ahead and do that here. So first, we want how many items there are in the section. All right. So number of items in section. This will simply be return colors.count because we're only going to support one section in this collection view. So therefore the number of items will be the same. The number of items in each section will be the same as the array of colors we get passed in. Then we'll have number of sections. Again, I mentioned we're only going to have one section, so we'll say return 1, like that. Now, next we'll have cell for item at index path. This is going to be a little bit more complicated than the other methods here. So when we think about collection views and even table views in UIKit, it goes and does this thing called recycling a cell or an item. So each cell that we want inside of our collection view or table view has some kind of reuse identifier. And this reuse identifier is what the collection view will use to be able to recycle and reuse each cell, so it doesn't have to keep rendering new cells over and over and over again. It can just reuse cells that's already loaded, and that makes things very snappy, very fast. SwiftUI's list and grids try to do that, but it doesn't do it in the most performant way possible. So that's why I say sometimes UIViewControllerRepresentable or UIViewRepresentable might be the best way to go if you're looking for the highest possible performance when it comes to tables, lists, or grids and collection views. All right, so the first thing that we're going to need is we're going to need to register a cell with an identifier. And to do that, we're going to go back into Make UIViewController, because in there is our best place to register a new item for our collection view. So we can go to where we're specifying our data source and delegate, and we'll say CV. CVC collection view dot register, and we'll say this is going to be called color cell dot self, and then we want for cell with reuse identifier, and this will be color cell dot reuse ID, like that. So now the next thing that we need to do, now that we have our cell actually registered, we need to create that cell. So inside of the same file, you could put this in another file, but for this video, we're going to have it be in this same file here. We'll say class color cell, and this will be a UI collection view cell. We'll say static let reuse ID. This is going to be a string, and we're going to set this equal to color underscore cell. All right, now that we have a reuse ID, the next thing that we need to do is have an init So we'll have init with a frame, and we'll say super init with a frame of frame, like that. And then it'll require that we have another initializer here. So, okay, Xcode, if you could cooperate. Required init with a coder of type NSCoder, and this fatal error of not supported. There we go. Now we'll have func set color we'll have this be underscore color info, or rather just color info. This will be name string color. All right. And inside of here, we will have a content configuration equals UI hosting configuration. And this will take in a single parameter that is a closure, so we can omit our parentheses entirely. And this closure should return some kind of view, a SwiftUI view. So we're going to use a SwiftUI view for the cell inside of our UIKit collection view cell, which is inside of our UI collection view, which is inside of our UI collection view controller, which is wrapped in a SwiftUI view using UIViewControllerRepresentable. I know that sounded odd, but trust me, it works. You can use SwiftUI views in UIKit, just like you can use UIKit views in SwiftUI. It's one of the great things about the introduction of SwiftUI. You can integrate it into the older stuff, or you can integrate the older stuff into the new stuff. It's great. It really is awesome. But what we'll do here is simply call color cell view with info color info like that. Now we don't have our color cell view yet. We'll go ahead and create that as well. So struct color cell view of type, we'll have that conform to view. Var info is of type name with a string, and color of type color, like that. Var body some view, and then in here it'll be as simple as saying vstack with a color. It'll just be, oh come on. It'll be info.color.frame width of, we'll say 50 and a height of 50. And then we'll have a dot corner radius. And the corner radius will be 10. And then we'll have a spacer with some text after that, which will be info.name. And our cell will be as simple as that. I also want to make this an accessibility element and have the accessibility label be text of info.name. Just like that as well. And there we go. Now, the last thing that we need to do is go to our coordinator again. All right. All right. Now, in here is where all of the meat and potatoes of populating our collection view comes in. Here we need to create our cell for our collection view. So we can do that by saying guard let cell equals collection view dot DQ reusable cell with reuse identifier of color cell dot reuse ID for index path as a color cell, else we simply want to return right? So this is going to return some kind of UI collection view cell. So instead of simply returning, we will return a blank UI collection view cell like that. Then we need to do cell.set color info, and that'll be so what we need to do here is I messed one thing up, and that is the fact that we need, instead of this being an array of color, this should be an array of tuples with a name of type string and a color of type color. Colors, we want all right. So we'll say name string color of type color like that. All right. Alrighty. And then make sure that our coordinator is fine here. Yep, colors, color, perfect. And then we need to modify our coordinator here. We'll have this again as well be a tuple of name of type string and then a color of type color like that. Same thing for our initializer. We'll say name string color color like that. All right, so now we can go to our set method here. And it'll simply be colors at the index path dot item. Okay. And then we need to return cell. And that's it. That is our full that is our full NS view control, or rather not NS view controller, UI view controller representable view here. Let's go back over what we just did, so that way you can grasp again what it is that we did, because we did do a lot here. So let's start from the top. We're importing SwiftUI. We're creating a structure called Colors Grid View. And this conforms to UIViewControllerRepresentable. This requires at a minimum 2 different methods to work: make UIViewController and update UIViewController. The third optional method that you can implement is make coordinator. Now, a coordinator is an object is an object that goes along with a UIViewControllerRepresentable struct that handles all of the things like delegation, data sources, stuff like that. Anything additional that should not be in the struct itself. So we have a property called colors that is an array of tuples, where each tuple has a name of type string and a color of type color. We have an initializer that takes in and initializes that property. Inside of make UIViewController, we are creating an instance of UI collection view flow layout. So everything gets laid out simply in a grid in our collection view. And then we are configuring that flow layout to scroll vertically, have minimum inter-item spacing and minimum line spacing to 20 points. We're setting the item size to 50 in width and 150 in height. All right. Then we are configuring the UI collection view controller that we are going to wrap in our SwiftUI view. We're giving it a data source and delegate. So we're setting our coordinator from our context as the delegate and data source. We later create this coordinator in make coordinator. We are registering a cell for our collection view with a given reuse identifier that is inside of our color cell class. And we'll take a look at that here in a second. And then we are returning that collection view controller. So now SwiftUI knows that we want to wrap this particular collection view controller into a SwiftUI view. Inside of make coordinator, we are simply returning an instance of our coordinator class. This coordinator class takes in the same colors array of tuples in its initializer. And then we're simply returning that object. Nothing is happening in update UIViewController. That method remains empty. Now, we have an extension of colors grid view where we create our coordinator class. This coordinator class conforms to NSObject, so it can communicate between UIKit and Swift and Objective-C and all that stuff. It can communicate back and forth properly as necessary. We're also conforming to UI collection view delegate and UI collection view data source. These are both protocols from UIKit that allow us to specify what kinds of things we want to happen with our collection view, such as how many rows, or rather how many items there are, how many sections there are, and then what the cells should actually look like. we have a property for that colors array that we mentioned, and then the initializer, again, takes that array and initializes the property. Then we are specifying what the cell for a given item at an index path should look like, where we are creating a cell by dequeuing a reusable cell from the collection view using a given identifier for a given index path. And then once that is done, we try to convert that to a color cell. Now, our color cell, as we'll see later, inherits from UI collection view cell. So this will, in fact, work because dequeue reusable cell also returns a UI collection view cell. If this casting doesn't succeed for whatever reason, we return a blank UI collection view cell. If we get past this point, we know that we have a color cell now. So we can call the set method of our color cell and pass in whatever instance of our tuple is being iterated over for our collection view to configure that cell, and then return the cell. Next, we're specifying a method to return the number of sections our collection view should have. We only want one, so we are returning one. Next, we want to know how many items are in each section, and because we only have one section, we simply just return the count property of our colors array, so it knows just put everything in one section. And that's it for our coordinator. Next, we have our color cell class, and this inherits, as I mentioned, from UI collection view cell. We needed to override an initializer that takes in a frame, and we're calling the super initializer version of this that will pass in the frame as well. We create a static constant called reuse ID that we used above in our colors grid view structure inside of make UIViewController to register our cell with the collection view. After our override of the initializer with a frame, we put in a required initializer that takes in an NS coder. This is required by UI collection view cell in UIKit. Almost every UIView subclass requires that we implement this initializer in some fashion. But this required initializer is used for storyboards. Something we're not using. So if that initializer gets called, we simply want the app to crash. Now, here we have a function called set that takes in a tuple of color info. So we have a name of type string and a color of type color. And then we're setting the content configuration of our cell to an instance of a UI hosting configuration, which is an object in SwiftUI that allows us to embed SwiftUI views into the UIKit collection view cell. And we're returning a color cell view from the only parameter in UI hosting configurations initializer that will return some kind of view. This color cell view takes in that same color info tuple. And then finally, we have our color cell view. This is a basic SwiftUI view that has a property for our color info. Inside of the body, we have a VStack that uses the color, sets its frame, and sets a corner radius, so it has rounded corners. We have a spacer, so it creates space between the color and the text beneath it for the name of the color. And then we're making sure that each individual cell is its own accessibility element and has an accessibility label. And that's it. That's all we need. Now we can put this into our content view. So I'm going to go to content view, and we'll see exactly how this comes together. All right. So inside of my constants file, I have an array of colors that matches that name and color tuple array. And inside of this, we'll simply have, I'm going to present this in a sheet. So we'll say at state private var is showing bool equals false. We'll have a button that says show colors grid, and we'll say is showing equals true. All right, then we'll have a sheet is presented, $ is showing, and then we'll have a content closure where we can give it our colors grid view. And you can see it takes in that array, so we'll pass it colors. Just like that. Now let's run our code. We have a successful build. Here's our simulator. Let's tap the button. And there is our sheet that contains our view controller. This view controller contains our collection view with a grid of colors. So that is how we can use UIViewControllerRepresentable to embed UIKit view controllers into SwiftUI views that we can use in our SwiftUI view hierarchies. I know it was a lot of work, but sometimes that's just how the cookie crumbles. Anyways, guys, that pretty much does it for this video. Thank you all so very much for watching, and we'll see you in the next video.